Yeah, people get to look at Mars live on YouTube for what it's worth. It's still rather big, but not quite as big as it was last month.
The wobbling autofocus, or is it extra hazy today?
That's the seeing. That's the turbulence in the atmosphere causing it.
Yeah.
Jeremy, could you send me tonight and last month's videos?
Oh yeah, I'll send those to you.
Yeah, just after the meeting, or tomorrow or something.
Yeah, sorry, I forgot about that.
No, that's all right. I mean, I got to get them back up on the website, from the club website. So I've been kind of slacking off.
Actually, I'm wondering, are you able to get that if you go to the YouTube recording? I don't know if you can download the video or.
I don't know.
Yeah.
I actually haven't tried. I've been just relying on you. So.
Yeah. All right. I just don't want to do it now because I don't want to risk losing bandwidth. And...
No, I don't want to do it until either later on or tomorrow, maybe.
All right. There's El Presidente.
Hey, Mike.
How's everybody?
Good.
Pretty good, Mike. How you doing?
Pretty good.
Now, are you seeing the polar cap at all?
It's just coming in and out. But you know what? If I move my chair, watch this. Even though the pier goes down 40 inches.
Are you outside?
Yeah, I'm in my shed.
You're still getting a vibration.
Yeah. Yeah, but the seeing is terrible because Mars is low and it's over the house, and I think it's transiting over the radon vent right now. But it's, after a split second, it clears up. You might see a feature or two.
It'll be better later on tonight, though, right?
I hope.
Yeah.
You can hope.
I mean, the higher it gets, the better.
And the fact that it's over the house doesn't help either because it's cold outside. The house is warm.
Right.
And you could tell because look how much it's wobbling.
Mm-hmm.
A lot of the wobble will change as it moves past the house. It'll still wobble, but not in this pattern.
Sorry, Lou, you mean the radon vent out of your house, right?
Yes, yeah.
Okay. I was just wanting to make sure there wasn't something that I hadn't heard of.
No. Yeah, it's either that or the it could be the bathroom vent. I don't know, but they're all vents. There's two vents right in the area now, so I don't know which one. I know the radon vent's always on. I don't know which one it's over. And by the time the meeting's over, though, it should be well past those.
Are we looking at Mars or Lou's nose?
That's my nose. You want to look at Uranus or something?
No, I'll pass.
Hey, we're on YouTube. Be careful.
I think this is the last day I'm going to leave my telescope set to planetary. I have to reconfigure it. Oh, Jeremy, I got a chance to do the blue snowball the other day with this configuration.
How did it go?
I posted it in the chat we have.
Mm-hmm.
I haven't looked at much lately. Just busy with work.
I tagged you on it. But if you scroll back, you'll see it.
All right. I'll have to.
I think Woody is causing it to vibrate like that.
Yeah. Tell Woody to be quiet.
Be a
Yeah.
perfect.
Can I add you as a co-host?
Yeah, sure.
All right.
It's going to be perfect this weekend for observing.
So what's the list for Blue Mountain this weekend?
Yeah. I mean, I'm actually thinking more of going to Green Lane.
I can foresee that for maybe a couple of hours or something. I don't know if
Yeah.
I can't do Blue Mountain.
Well, the moon comes up at 10:30.
Yeah. That's why I'm
So-
thinking Green Lane.
Green Lane makes sense for earlier in the evening.
Yeah. Yeah, work is crazy for me right now. I'm not looking forward to leaving the house at like 4 o'clock and then getting home at midnight.
Mhm.
You guys are welcome to stop by here if you'd like.
You're welcome to stop by Green Lane.
Now, I might bring my laptop over there and hang out with you guys.
A light, sir. Sir.
Well, the last time I was there, we did get visited by the constable. So,
Oh, they're very nice.
but they were cool. They were very cool. So,
Yeah, they're nice people. Hey,
Yeah,
Jeremy,
on a first name basis with them. And that's not nearly as sketchy as it sounds.
Yeah, well, last time we were there with them, they told us all their hiding spots. They were explaining to us how their equipment works. It's good to be friends with the cops.
Yeah, so I'm leaning toward Green Lane tomorrow night. I think that's what I'll do. Yeah, I don't know if other folks might want to go up to Blue Mountain. I think Al said that he might go up there.
did Wayne? I think Wayne and Barb might be going up.
Yeah,
Maybe they're going to French Creek.
Wayne's on here. So
Yeah, we're probably going to go to the mountain.
Why not?
Andrew?
Am I not seeing everybody?
Yeah, well, that's because Lou's sharing his screen. You can't get gallery view.
I don't have to share it if you guys don't want to see this.
I just didn't realize that how many there. I'm seeing 6 people. There's actually 13 people on. So
Yeah, I see Andrew. Andrew, you have a report, right? Just give me a thumbs up.
There he goes.
Okay.
You can make it wider, Brian.
Yeah, I just did that.
yeah, I did too. I'm just kind of leaving Mars over in the corner here.
Yeah, that's why I left it off to the side. I can
Andrew,
move-
I'm sorry, Andrew, I got a question for you.
What's that?
Do you have Al Lamperti's moon map and stuff from the last Star Party?
Yeah, I have that.
Okay, great, thank you. I just visited him to get some stuff from the auction, and he asked about it, and I was pretty sure that I was pretty sure that you still had it.
Is he on?
I don't think so, not
I
yet.
don't see him. I think I'll just keep, unless he needs it for another outreach event. I think it makes more sense for me to keep it.
That's what he
'Cause,
said.
I'll always be at the star parties,
Right.
90% of the time, 99% of the time. So
Yeah. Yeah. He said he'll be at the next one also.
yeah. Okay, good.
You've got the projector and the table and the bag.
Yes,
right?
I do.
Okay.
Yes, I do.
And Jan, do you have the PA?
Yes.
Okay. Everything that I had's accounted for.
Mhm.
And I do have everybody up on the screen now.
Yeah, I'm going to use it tomorrow night, actually. I'm doing like a little outreach event with a synagogue in Broomall
Okay.
with a constellation tour. So
Okay, cool.
Nice.
going to be a nice night.
We
No,
got
the
really
last-
lucky this year. Weather
The
is so nice.
The last time I was out was with you, Lou.
Yeah, I mean, we got till Tuesday. It's going to be in the 70s. Is that right?
Mm-hmm.
I think
That's what I
so.
heard.
Yeah.
And no rain until Wednesday.
Yeah, Wednesday. I think that's when the rain comes in.
Hey, Jeremy,
yeah, Roy.
I met your colleague Larry today
Yeah, he told me, he texted me.
at Home Depot. I tried to get him to join the club, and he kind of like, yeah, well, Jeremy's been trying to do that for years. He rolled his eyes, and I said, I'm just teasing you.
Yeah, Larry's a good guy. I like him.
Yeah, he seems to be very nice. He and his wife were at Home Depot.
So how did you guys recognize each other?
He was wearing an observatory T-shirt.
Oh, okay, so you figured he must have been a weirdo.
Yeah. So I asked him where his observatory was, and he said Villanova. And then he looked down and saw his shirt, and he said, "Oh, this is a friend of mine. This one belongs to a friend of mine." And we just started talking from there.
I think it was Wasatonic Observatory. Yeah, the guy Rick Wasatonic, he did the observations that Ed Guinan talked about.
Okay.
Yeah, he's kind of like a research scientist or something in the department. I don't know exactly what his title is.
Yeah, he said Larry said that he had given a talk to the club a couple of years ago. Or several years.
Yeah, I think it was about 15 or 20 years ago.
Wow.
He's due.
Yeah, maybe I'll try to get him back at some point. I mean, he used to be doing a lot more work with students, so he would have like a student present it.
Mm-hmm.
The funny thing was Marilyn gave me a list of all the speakers, and there was like a little note next to him that said hard to get. So I teased him about that. Oh, you're playing hard to get. Maybe she tried to schedule him a few times and he was traveling or busy with teaching.
Maybe it was just hard to get.
Yeah, could be.
How you guys doing?
Good. How you doing?
Yeah, actually, this is one of those rare meetings that Marie wants to attend.
Hi, Marie.
Yeah.
Astronomy. She's not here yet. She'll be in a second.
Oh, we have high standards for attendees. We have to make sure.
Yeah. Well, no, you don't. You haven't kicked me out yet, so you have pretty damn low standards.
Yeah, I said, well, let Marie in. I don't know about you though.
Hey, Bill, it's how's the new job?
It's great. It's
Good.
great. You know, it has all the good things you want a new job to have.
Good.
So that's great. You know,
Mhm.
just
That's sex, drugs, and rock and roll.
yeah, and you know, and with the one good side about COVID, of course, is that instead of my normal every 2 or 3 weeks fly somewhere schedule, I have sit on my fat ass schedule.
You're parked at home.
Yeah. So let's see how we're doing, people.
Got a quarter office.
Yes. Actually, I have a corner of my desk office.
Nice short commute, not too much traffic.
You'd be surprised.
Yeah.
Wow. We are 166 people today. Wow.
What?
It
On
says-
on YouTube.
Oh, no, I'm sorry. I screwed up.
That's base 2.
No, I clicked the button, but it didn't take. So that's so weird. Yeah, so wait a second. I'm confused. It says 100. I have member status active. Let me reset just to make sure this thing is not working correctly. And then I'm searching for, it's showing 166 people. Isn't that weird? You would have thought there'd be less.
Well, that could be right, because you know how many members we got this month? 9. I think that's a record.
That's amazing.
Wow. Yeah,
That's
we have no expired members in our database right now. So 166 is the active.
So sending out Big Tony to collect the renewals was a good.
Big Tony. Yeah, exactly.
I think that helped.
Yeah, Jimmy the Thumbreaker retired, and I had to find somebody else.
No, Tony's good. He's tough but fair.
If you pay me now, it's 40. If you pay me later, it's 60.
He gives you a little bit of a grace period.
Yeah.
Not much of one, but a little bit.
Yeah. Gives you time to say grace before he breaks your leg, right?
That's right.
Right.
Hey, Mary Lou, welcome.
Hello, thank you.
So how was your commute out here?
Traffic was very light.
Yeah.
Wonderful.
I think you'll find we're a group of characters here. So.
Oh, well, that's good to
There's
know.
Al. There's Al and Birdie right there.
You got 9 new members this month. That's great.
Yeah.
Wow.
It's been a good year, actually, for the membership.
Yeah, considering I think this has been the best. Well, for what I've only been doing it for a couple of years, but it's this is definitely the best year. Go figure.
Well, they said that astronomy sales of telescopes is way up also.
I did
Yeah.
read something about that. So
So did I. Yeah.
They're
It's a good
backordered.
hobby to have. It's socially distanced.
yeah.
Yeah, no, Sky's
What are we
Unlimited.
watching on the screen? Who's
That's Mars. There's the telescope back there.
The guy in the red.
Thank
the
you,
red
Lou.
screen.
What size telescope you got?
The 8-inch SET.
Oh, very good. That's what I have too.
Speaking of 8-inch SCTs, I received yet another donation this month.
You did.
Yeah, an 8-inch Mead, LX something or another.
LX 200.
I have a 90.
Yeah.
LX 90.
We were also contacted about a, I think a 14-inch Dob.
I'll take it.
I meant to.
Oh my God! Don't. Yeah, take it, but don't take it. Okay.
I meant to circulate that. I will circulate that.
Yeah. So I put a whole bunch of boxes in the storage room. You know, and we're starting to fill up already. Isn't that crazy?
Mm-hmm.
Janet, do you have a report?
Yes.
Okay, thanks.
So Lou, is the 8-inch Mead going in the auction?
I don't know.
Oh, okay.
What to ask? So we didn't get any instructions to or to not do it. And I have to look up the guy's name, but you know, he dropped it off. We gave him. I certainly signed him a receipt for receiving it. And one of the things I said was we have to have someone in the club evaluate it for tax purposes. So it's a scope. It is all the electronics. It is actually one of those wheelies. You know, those wheelie things for wheeling out like a big tripod and scope together.
Mm-hmm.
That's great.
Yeah. So, and we'll see how it goes. But, you know, wouldn't be a month if I didn't get, you know, a donation, right? I mean, it's such a thing. We've had 2 telescope rentals in a row, and do you guys know that Mr. Lamb is going to take over rentals? He actually already has.
I didn't know that.
Yep. He was silly enough to raise his hand, and I didn't yell at him and say no.
Mm-hmm.
Funny how that works, right?
I might have talked him into that.
Ah.
What is your scheme for telescope rentals?
If you have an easy $1,000 you want to give us, we're happy to have it. Perhaps a little less. You know, it's just saying. Yeah. Now it is. We have I think it's 5 different telescope setups that were set up just brilliantly. Thank you, Jan. You know, Joe was super impressed, by the way, with, you know, we not only have the scopes, but we have these bags with like books to read and extra eyepieces and these great labels. Everything was great. So thank you. So Joe is not going to be here, unfortunately, tonight because, you know, it is on the one hand, a very happy occasion is his eldest daughter's birthday. But on the other hand, you know, and Kathleen has a new baby. So Joe and Ann would be very happy to see him. But it turns out that Kathleen's husband now has COVID.
Oh boy.
Oh, no.
Yeah, Darren is a doctor, a surgeon actually, and you know works at Jeff, and he's come down, so not good at all. Yeah, Yeah. Say hi, Marie.
Hi, Marie. Hi. We don't see you.
Yeah.
Oh, there you are.
It's a relatively narrow. There it is.
There she is. Hi.
Oh, you know what I should do? Yeah, no, I'll get rid of my funny background.
Right.
Yeah. And there it is. There you go. Now she can feel self-conscious for being here.
Mm.
So the auction seems to be going very well.
Yes.
It's going great. Yes.
Yeah. Not so much auctioning. It's a lot of pre-buys I've seen so far, right?
Yes.
Yeah.
There's been some big spenders, yeah.
Well,
I've had two.
I bet people are going to be waiting until the very end to do all the bidding. So.
Well, I've had two things bought out from under me.
I've had one.
Well, you know, that's the way it goes.
Mhm.
Yeah, I'm not complaining. I'm happy that people are buying stuff.
Mhm.
Mm-hmm.
It just surprises me that amateur astronomers who normally are known for incredible patience while they wait for stars, planets, and so forth to align perfectly can't stand to watch an auction long enough without grabbing something with a buy it now.
I don't know what you call it, but I don't call it patience.
Well, it's hard to find equipment now. Everybody's sold out of everything.
Yeah.
Mhm.
Yeah, well, I guess
can't
that.
find a $90 dispersion corrector for this stupid thing.
Well, I guess it's a good sign then for astronomy.
You could buy a Dob that doesn't need a dispersion corrector.
If you look,
Just
you
a
might
color
need it if you
corrector.
look too low.
You could be a true visual observer.
I graduated to real astronomy. Put your big boy pants on and start doing astrophotography. All right.
Wow. Thanks for explaining that for us. We were very confused.
Sue and Jeremy have a love-hate relationship with their telescopes.
Yeah, we complement each other.
With each other's telescopes.
Opposites attract.
Yeah. So my friend, the great visual astronomer Keith Murdoch, the first person in all of history to view our one-time planet 10, the very first person, likes to talk about personal photons, and so he cares about that. Just saying.
What's a personal photon?
A photon you get.
Oh.
Right? A photon that actually hits your eyeballs.
Oh, yes, I've talked about that.
It's not like a selfie, but that's
I have talked about that.
That's a personal photo one. Yeah, that's absolutely true. Here, let me flip back to the full.
I don't understand that argument. What's the difference if you see the photon or if you see it?
It hits your eyeballs, and then it's never going to hit anything else ever again.
That's being selfish, isn't it? You can't share the photons.
Well, the physics of it, the only way it works is if you stand in front of me, then it could be your personal photon, because they're directional, in case you wondered.
Share the photons, okay?
Share the photons. There you go.
But I think to a small child, having a personal photon from time to time is important.
Yes.
Yeah, I agree. Lou, will you stop sharing?
Oh, absolutely.
Thank you.
Yep.
So what you're saying is next time Bree and I get in an argument, I should remind her that she's lucky to be getting my personal photons.
Exactly. And an immediate, maybe we'll learn from medieval, astronomy. They used to think that light emitted from our eyes instead of came in. So
wait, you're not newlyweds anymore? Wait, the bigger news is you're not newlyweds anymore, Andrew?
When does one become not?
Well, apparently, if you need a plot, a strategy for dealing with arguments.
It's over. It's over.
Yep. We've given advice at weddings before to more newlywed couples, so I think we've reached a threshold.
Yep. Okay. I've had a friend on my desk for a while, but I think it's time to send him away. He's starting to molt.
Just
put them outside. The squirrels will take it.
No, I know, no, but it's just I realized, oh, it's that 1 or 2 inches away from just being this lovely thing on my desk to suddenly something disgusting.
Rest in pieces. Did it have a name?
Yeah, let's name him right now. Marjorie. I like that. Why not?
Fits.
It's my mom's name.
We're getting there. 1 more minute. Do we have how many people we got? We got 20 people. That's good.
Got another 14 on YouTube.
It's good.
Usually we pick up a few more. I guess people don't want to sit in the business meetings.
Yep. That looks like too generic a flagon for you, Jeremy. You should have like, a real, maybe a German mug or something like that with character.
That's a skull.
Yeah.
Something.
Exactly.
But does Andrew have the same?
Cheers.
Did you steal that?
You're
Did
drinking
you
a darker
steal-
beer, Jeremy.
Did you steal that from Galiftes? Tell the truth.
Mine's from work.
Yeah. Yep. So can I ask one piece of just technical? Who is our election warden today? Who's going to handle DVAA election this time around?
Wait, weren't they called out to Nevada to help?
Yeah, no, I know. I mean, elections are on the mind, obviously, so it is. But
well, the process is
It can't
simpler
be-
now because we have the electronic system.
yeah, absolutely. But be the same token, who's going to be in charge? I keep looking at Jeremy because I keep doing.
Hiding now.
Well, but we have. Janet, didn't you set it up for online voting?
Yeah, it's it's set up, but it was it's just a mock. It's not active. It's in test mode.
Yes, but the key point is someone has to own the actual people voted. Here's what the thing is, right? And by the way, did we set up our meeting? Have we booked it?
Well,
Yes.
This
Yes.
is
It's
me?
December. It's yes. Yes.
Okay. Cool.
So seeing as it's 7:31, we may as well launch right into that. I have brought with me for the highlight my own copy of La Divina Commedia. So I'm looking forward to this evening. I don't have a slideshow, so you don't all have to cheer about that. I don't have a whole lot to report except that we do have elections in December. That meeting is, I'm pretty sure it's December 13th. I think that's that Sunday. And it's going to be at 1 o'clock and it will be via Zoom, just like this meeting is.
Well, I'll bring the donuts like always.
I was going to say, bring the donuts. Right now, the problem we have is that some of the offices are term limited, and that would include secretary. And we need somebody else to take on that role of secretary, which involves also taking responsibility for our fabulous newsletter. Now, to a certain extent, our newsletter is self-driving. There are a number of regular contributors who will continue to contribute, and Janet, who's been handling this, doing a fabulous job with this, has offered to assist anyone who takes on. But we absolutely need to have a secretary. The only other thing the secretary needs to do is take minutes at meetings. And all I'm going to say about that is that I think there has generally been not a great understanding of what kind of minutes are required. And the fact that minutes are read, it's not an action item. We don't read them at the meeting. We read them in advance of the meeting. There's a motion to approve, to edit, to make revisions, or to move on. We have historically done things at our meetings that would suggest that nobody's ever read Robert's Rules of Order. So the threshold is much lower than one would think it is. But we absolutely need to have a secretary. I have spoken to most of the committee chairs. I've certainly emailed all the committee chairs. Everybody's agreed to stay on with 1 or 2 changes. Joe Lamb's going to take on rentals, which we're delighted to see. So Lou Berman will take off one hat at least. But I know there's some other people who are interested in helping out, and I will reach out to you with some ideas for how you can help us out. And the election is December 13th. And once we have that set up online, you'll get emails, vote, and we will move on from there. And with that, I don't really have anything else except to say, do go to the auction before anything you want is bought out from under you. Right now, probably the most valuable item on there is a Teleview baseball hat signed by Al Nagler. That is absolutely priceless. And
we'll put a price to it.
I personally just bid that up to $5. So, and a couple of other things I was looking at got bought really fast before I could do anything about them. But it's raised a lot of money for us so far, and that's great. So, and thanks to everybody who's contributed to that. That was a Herculean effort, and so far it's turning out very nicely. So, with that in mind, let me move, as I usually do, in the direction we would be going if we were back at Radnor. And I'll go right to Brian.
Okay, we've got, I believe it's a record, at least since I've been doing this, of 9 new members this month. Sean Durkin, Henry White, I believe he's here.
Hello, Henry.
Mark Anderson, Philip Zakilars. I'm probably butchering your last name, but if you want to unmute and let me know how to pronounce that, that'd be great.
Yeah, it's Zakilars.
Zakilars? Okay, I was close.
Oh, welcome aboard.
Welcome.
Corey Doubts, Jim McCambridge, Justin Williams, Jason Winter, and Daniel Gray. So, well, Philip and Henry, welcome.
Yeah, I'm delighted Mark Anderson joined. I just told him about the group about a month ago. So that's excellent. Sorry he's not here tonight, but he lives two blocks away from me, and I'll be sure to buttonhole him.
Mm-hmm. Corey, by the way, is one of the big spenders at the auction, so thank you.
Good deal.
All right, and next we go to Lewis.
Yes, so what can I say? Firstly, we have 166 members, which is fabulous. But there's going to be a bizarre thing that happens real soon. We're going to have 0 members, and then we have to remember. And we just have to make sure everyone who just signed up recently are going to not expire at the end of this year, but expire next year. I think it's already set up to make sure that happens automatically, but we want to make sure we didn't have any flubs. But every single person who is on our mailing list and has a valid email will receive, starting, I think it is literally December 1st, but it may be a day or two before or after, a reminder. Please come to the website and re-up. You'll get 3 emails if you don't. Anytime you visit the website, in the upper right-hand corner, it's going to show a red $. And renewal is really, really easy. Last time I did it took about 4 or 5 minutes. Very easy to do. And if for any reason it doesn't work for you, on the website there is a support menu item. Click on support, and it gives you a phone number to call a real live person, and they will help you walk through for that. So your dollars really, really help, even more so when we're in COVID land. Help with programs, help with expenses, other expenses, and like Zoom and stuff. So thank you very much, and I'm looking forward to someone pulling a coup and voting me out. But since I'm running unopposed, there's probably very little chance of it. Dreams can always happen, though.
So we go from Lewis to Lou, who is astrophotography chair. Lou, any report? And don't forget to unmute yourself.
Yeah. Nothing I can think of right now. One thing I did want to mention about the Delaware group, anyone who's interested in astrophotography, is a bunch of us that meet on Tuesdays. So you might want to look into their website. I know I'm supposed to promote us, but there's a lot of experienced astrophotographers there.
It's all good.
Yeah, So that's a regular meeting once a week. And if you have any questions, you can just contact me and, I'll get you the link and the information. But I have nothing planned in the near future. All the planets are going away. So we have to wait till I just got sucked into this planetary business. I never did it before. So then we have to wait till June.
We got the conjunction of Jupiter and Saturn.
They're going to be so low though that
Too low for you.
yeah, I don't have one of the dispersion corrector, and then there's also trees. And yeah,
It's a poor tradesman who blames his tools.
Yeah, let's go back to deep sky stuff. So
Yeah, seriously. I mean, you can do M13 with your eyes closed.
when it's on the other side of the planet,
Especially if you smack yourself in the eye. Yeah, that you can see it real well.
Yeah.
yeah. So that's all I got. Nothing.
Is that what you meant?
All right. Outreach, Janet.
Yeah, so I'm Janet Rush. I'm Outreach Chair, and Andrew told you last week, or last month, I mean, about the COVID-friendly format that we've been doing, which is working well. It's pretty labor intensive, but it does work. And I guess we'll be doing that again at the Star Party coming up in a couple of weeks. The calendar's also filling up with more modest things that basically Zoom presentations to groups and requests to do star tours with just with a laser pointer and constellations on a smaller scale than we did at Valley Forge. So if there's anyone who'd like to be involved in those kind of events, I'd appreciate it if you'd send me a note that say that you're up for it, because it's pretty easy, and we are getting requests, and I don't want to say no all the time, so that's good. I was going to say a word too about the auction. I know Harold started to say something, but it's really going well. The people have no complaints about the website. It seems to work well. So please, if you haven't looked yet, take a look at it just to see what it's like. It's at www.32auctions.com/DVAA 2020. And there's a link right on the homepage of our website. So we have there are about, let's see, 46 objects or 46 items. 25 of them have bids. We've only been up for a week, and that's doing well. 8 have already been purchased, and the total amount that the auction has made so far is $2,440. So really doing well after only 1 week. And I thank everyone who helped with donations and setting it up and so on. The auction is scheduled to end on Black Friday at 9 p.m. So that's probably when bidding will get really, really intense and interesting. And the last thing I want to say is about Secretary. I do have to give it up. It's been fun. It's a really great way to get to know more people around the club. And for anyone who's considering nominating themselves for this, I will say you don't have to know all that much astronomy, because I certainly don't. The contributors are the ones who provide all the brain power and the expertise, and you just basically have to assemble it. And we've got great reviewers that point out any issues before the draft actually goes out. So it's really not a hard job. I say it takes about 10 to 15 hours a month, I'd say. But you can do it at any time, and you can do it wherever you are. So it's not bad at all. So we hope someone will take that on.
Thank you.
Janet. So we actually hope to do some observing, especially with a beautiful weekend like this coming up. And Andrew, you have an observing report, do you not?
I do. Let me share my screen here. All right. Thanks, Harold. Do you guys see the zoom on the side?
Yeah.
What do you mean?
I don't want any.
Oh no. We're seeing
Guys can't see
people's screens up top, so it's not intruding.
Okay. Well, thanks, Harold. My name is Andrew Hitchner. For everyone new, I'm the observing chair, and I give these observing reports each month at the monthly meetings, and I also call all the star parties. So if I cancel the star party and it comes up clear, you know who to blame. But on that note, I do want to give a shout out to everybody who did attend the star party in October. It was supposed to be more clear than it was. However, it was pretty much overcast, but we were able to give a really good show. So Gary was there with his tablet, and we were able to zoom around. I think it was Sky Safari or whatever planetarium app he had, and kind of do like a virtual planetarium tour. And then Wayne actually, through his telescope, was able to shoot some objects through the clouds because they were kind of like a high layer, semi-transparent cloud. So that was really good. So thanks for everyone coming out. And our next star party is November 21st. It's an early one. I think it's a 5 o'clock start time because we tend to get around the sunset time. So that will be the last one for the year until next year. So without further ado, the observing report for November 2020. And right off the back, Astronomical League Award. Congratulations to Al Lamperti for completing the NOVA program, the gold program. If you remember last month, Al completed the silver program. So to get the gold, he made an additional 50 observations of NOVA objects to get a total of 100 observations. So congratulations, Al. I don't know when he's doing all this observing. If he has any secrets, I would love to know. So going on to the main topic, there was a pretty historical event on October 31st. There was an interesting phenomenon that happened, and I made that the topic of this observing talk. So we're going to talk, of course, about not that kind, blue moons. Not really that kind either. Of course, we all know that the moon isn't actually blue for blue moons. And I thought that this might be interesting, and I did some research, and there's actually a little bit of controversy to what a blue moon is, and it was pretty interesting. So this will be a little shorter talk, but I think you'll like it. So I'll go through the lunar cycle in general because you need to have an understanding of that, and then a little bit of history of blue moon. You can actually see a blue-ish moon. It's not what we're talking about here, but it's actually physically seeing a blue moon. And then I'll talk a little bit about other popular full moons out there. So the lunar cycle, of course, the moon goes through the cyclical phases, from waxing to waning, as the Earth, Sun, and Moon all progress through their orbits. So a lunar cycle from new moon to new moon, or however you want to do it, is 29.53 days. And that's called a synodic month from way back in the Greek and Roman eras. And a tropical year, so the time from the Earth to go entirely around the sun, takes 365.24 days. So if you divide those two numbers, then that leads to 12.37 lunations or lunar cycles a year. So as you can see right off the bat, we don't have decimal days, right? So there's a problem here because we don't get a perfect 12 lunar cycles in a year. So of course the Gregorian calendar, which we're on, has 12 months in a year. So generally there is one full moon a month. It all works out great. But the date of the full moon falls back approximately one day each month. And then this accumulates up to about 11 extra days over the 12 cycles. And then that's in 1 year. And then the next year, there'll be another 11 extra days, and the next year, another. So this adds up over a number of years. Now, all of a sudden, we'll get 2 full moons in 1 month. And then that extra moon is a blue moon. Now, that extra moon, though, which extra moon are we talking about? Are we talking about the second in the month or the extra one in the season? So it actually depends on who you ask. So the term blue moon was coined in the Maine Farmer's Almanac, and they described it as an extra full moon in one of the 4 seasons. So it leads to 4 full moons in a season instead of 3. So we have 4 seasons. If you divide 12 by 4, we'll get 3 full moons, right, in a season. Well, the 3rd full moon out of the 4 is a blue moon. Now, in 1946, an author of Sky and Telescope tried to decipher the Maine Farmer's Almanac's practice about how they determined this. And they made an error where they didn't really have enough back issues of the Farmer's Almanac to come up with the correct cycle. So this led to the colloquial, in quotes, misunderstanding of the definition, where they came up with the 2nd full moon in a month. So we have these 2 definitions, and it's kind of, you know, you have the classic definition first termed in the Maine Farmer's Almanac in 1937. And now we have this really popular Sky and Telescope magazine that came up with this other definition, which was further made popular by, I don't know if you remember, the radio show Stardate. And then also, of course, the really popular question in Trivial Pursuit that made it more popular. So you kind of have 2 definitions, and which one's right? Well, to be honest, a blue moon is just an ambiguous term that we give to an extra moon from an ambiguous calendar system that we make up. But if you want to be picky, don't be too picky. Even as Charles Federer, the Sky and Telescope founding editor, said, even if the calendarical meaning is new, there's no harm in it. It's just something fun to talk about, and it brings attraction to people to astronomy. So it's not really false information out there. Again, it's kind of an ambiguous term, if you will. Anyway, I thought that was really interesting because I, for one, go around saying that, it's the 2nd full moon in a month, which is true and not true at the same time. Now, visibly full moons. So you can see a moon that has a bluish tint. And this can be due in the very specific conditions of dust and smoke in the atmosphere. And the key is that you need particles slightly wider than the wavelength of red light, so about 0.7 microns. And you need only particles at that size. You can't have any other particles of any other size because then the other types of scattering will dominate, such as the Rayleigh scattering that makes the sky blue. So we want to scatter red light in this case. So we need a very specific kind and size of particles in the atmosphere. And it just so happens that volcanic eruptions do a good job of spewing out these size particles, as well as specific kinds of forest fires. So the eruption of Krakatoa actually made blue moons, physically blue moons, for 3 years. Actually, they have accounts of the moon looking blue for 3 years. There were forest fires in Canada and Sweden up in the northern latitudes in 1950 that made the blue look moon. And then, of course, the eruption of Mount St. Helens in 1980 also made the moon look slightly blue. So now these are all pretty cataclysmic events. So I'm not sure if we would be particularly excited to see a visibly blue moon, but it does happen from time to time. And here's a nice picture. This is taken from Wikipedia. I believe that this was in around 1980 or so. No other popular full moons. So the Farmer's Almanac does name every single full moon. Take it for what you will. There's some other popular names: a strawberry moon in June. That's the name given to the last full moon of spring. There's the harvest moon in September. That is the full moon closest to the autumnal equinox. And then we have the harvest moon in October, which we just had. Now, I find it interesting that all of these have a kind of reddish term to them. And there's a picture of the red moon there. Red moons are a lot more common than blue moons, physically blue moons, because the same phenomenon that makes our sky blue, the Rayleigh scattering, is also what's causing these moons to be red. So they're a lot more popular to see. And I believe that's all I have. So thanks for listening.
Great job.
Thanks a lot, Andrew. Before we go to our guest, Lou, you had one more thing you wanted to mention. Unmute yourself, Lou. And he left.
Yeah, I'm here.
Oh, there.
Yeah.
Talk to me.
Yeah, I don't know if you guys, all of you saw this, but if you remember this weekend, Dick Steinberg shared this beautiful picture of Mars. Should you guys take a look at the group?
Yep.
Anyway, I reached out to the guy who took it. His name is Brian Combs. And I asked him if he'd be willing to present to us his method on data collection and processing. He uses one of many pieces of software, but one in particular, which I'm not familiar with, and I've been wanting to learn, but it's kind of confusing. It's called WinJupos, and it does a wonderful job at rotating the data. So you can stack your data, and it's like stacking stacks upon stacks. So if you get enough space on your computer that when you're collecting it, and you get, I don't know, an hour, 2 hours of data, it will sort through that. So if anybody is interested, please let me know, because then I know the people in the Delaware group are interested. I'd like to make it a joint, workshop. It'll be a real treat, because not very many people, there's not very many tutorials either on YouTube of how to use WinJupos. It's a very powerful piece of software for those of you interested in planetary photography.
Cool.
All right.
Thank you, Lou.
Sure.
Well, I know most of you would rather be watching what one 6-year-old characterized as the map show that's been going on for 2 weeks or a week or so. But I think this is much more exciting. I remember reading Dante in college in Italian, and he virtually invented the language. I'd taken Latin for 4 years, and there's very few nice Jewish boys who enter the priesthood, so it didn't make a whole lot of sense to stay with that. And I switched to Italian, and really, really enjoyed Dante. He's truly amazing. So when Jeremy told me what tonight's program was, I was like, oh, okay, this is just perfect. So very excited to hear from Mary Lou. Jeremy, I'll let you do the setup. I am going to kill my videos so you don't have to look at me, and I ask you all to do the same so that the throughput's better. And we'll see you on the other side of Mary Lou's presentation.
All right. Thanks very much, Harold. Just a couple of quick announcements here. So if you're not the speaker, please mute your mic during the presentation. We will have opportunities for questions, but we'll just try to keep the background noise down. Little promotion here. Some of us are planning on doing an observing session tomorrow night. So we'll probably have a little discussion after the meeting is over, and I'll put something out to the Yahoo group afterwards. So I think some of us are going to be at Green Lane and some of us are going to be at Blue Mountain. Right. So a little preview. Next month, we're going to have Dr. Emmanuel Sean. He's a postdoc at Lawrence Berkeley National Lab, and his talk will be called Cosmic Shadow Theater. So I'll let you think about what that means. Cosmic Shadow Theater. All right, so tonight I'm very happy to introduce someone that I've known for quite a while, Dr. Mary Lou West. So Mary Lou West has been excited about astronomy for many years. I didn't make that up. That's the official first sentence in her bio. So Mary Lou has been a professor at Montclair State University in New Jersey. She technically retired in 2012, but I think is just about as active as ever. She completed her undergraduate and graduate degrees at Cornell University and Columbia, places you may have heard of. She's very active in outreach and education. She's been very active in several amateur astronomy clubs in New Jersey and has been leading public astronomy nights at MSU for quite some time. She has diverse research interests. She looks at properties of meteorites, sunspots, solar activity and its effect on the Earth, as well as spectroscopy and looking for exoplanets. So tonight she's going to be telling us about kind of an interesting topic that I think Mary Lou will explain, started as a joint venture with a history professor. And this will be entitled Medieval Astronomy, What Dante Knew in 1300. So we have about 50 people here tonight, so please join me in welcoming Mary Lou West. All right, take it away.
Okay, can everybody see the title slide?
Yes, we can.
Good.
Okay. So I want to say something first to Lou about WinJupos. It is a very powerful stacking sort of program. One of my friends, Cliff Ashcraft, uses it a lot. So he might be another one that you could talk to. Okay, so this started out, as Jeremy said, with a friend who is a physicist who is team teaching a class with a historian, and they wanted to do something about astronomy and history, and I got sucked into it. So I had never read Dante before, so I read not the whole thing, but a fair amount of the book. And I want to ask you to do a favor if you could. My motto for life is pay attention, be amazed, and tell about it. And this is from a poem by poet Mary Oliver. So I like poetry as well. And so my question at the end will be, what will you tell someone about this topic tomorrow? So I always think it's good to have a pencil and paper handy. If I were actually in the room with you, I would make sure that you did that, but I'm not going to give you out anything tonight. So here's a picture of the book. The translation I was using and they used in the class was this one. The Divine Comedy is an epic poem. It is in Italian. The three parts of it are the Inferno, the Purgatorio, and Paradiso. And the plot is that Dante and his love Beatrice are guided by the ancient poet Virgil to go through the three levels of the universe. And they explore sin, redemption from sin, and what the universe is like. And so especially the Paradiso is very interesting to astronomy. And Dante was very well read on the astronomy at his time. So I wanted to tell you some of the things that he knew, as anybody who is well educated at that point would know. And what happened to it? Come back. Okay, known observations. So they knew certainly a lot about time periods. They knew the Earth was round. Everybody knew the Earth was round if they were educated at all. They knew about the constellations. They knew about the Zodiac. And then the apparent motions of planets against the background of the Zodiac and retrograde motion, which had been known for 2,000 years at this point and baffled a lot of people. They knew that the sun's apparent speed through the constellation varies. And they knew about the precession of the equinoxes, which was very disturbing to them at that time. So they had a lot of data. And people often say, oh, the data speaks for itself. But no, it doesn't. Data does not speak for itself. As people have said, I've been in a whole room full of data and it's been absolutely silent. The data has to be interpreted or have a model or an explanation for what it might mean. So we're going to talk about that and what does a model mean? What does meaning mean? And what is understanding? Dante would have loved this sort of philosophical discussion. So I think explanation can mean several things. The easiest one is in words. This phenomenon over here depends on that phenomenon over there. Then you get a little more technical and do some mathematics. And you can say, well, if you draw a picture, then if this angle increases over here, then that angle over there increases also, or decreases or whatever. So things have a correlation in their behavior. Then you could get a little more technical and have a graph, and it could be qualitative or quantitative. So qualitative is just sort of, you have the X and Y axes and you say, well, it goes up like this, or it goes down like that, or maybe a little curvy. And quantitative is where you really say, if this goes down by twice, that will go down by twice as well. Get real numbers in there. Show me the numbers. Another way to do mathematics is just to have a table of numerical values, a whole list of times, a whole list of angles, or something like that. Really great if you can get an equation for how this influences that. That's rather difficult in many cases. And then finally, the best thing is to do some physics. Because of Newton's laws of motion, this force over here causes that motion over there, and then we really feel like we can understand it. Some of the simple observations involve time periods. And these are useful for calendars and for holidays. People have used astronomy for calendars since 1000 BCE. And it's always been very useful. First, there's day and night, and we know that they change in length. And in the summer, you have lots of daylight, and in the winter, you have less of it. And up until recently, nobody had the time change that we just had. Then we have the length of the year and the seasons, the quarters of the year. These are very useful for people who live in temperate zones to do agriculture that has a bi-period. And then we have the days of the week. So what did these days of the week come from? Well, these are the way we say them in English. And if you know Italian or French or German or some other language or Spanish, it's fun to say the days of the week in those languages as well. So we all know what these mean or what they came from. Is sometimes a little bit more difficult. They are turned out to be names of the ancient things that moved in the sky. So Sunday, of course, is the day of the sun. Monday is Moon's Day, and evidently an O fell out there. We had a vowel shift at some point in the past. And then you look down at the bottom, Saturday is Saturn's Day. I guess the N fell out at some point as well. But the ones in the middle, Tuesday through Friday, are not obvious to us English speakers. And what I've been told is that in the ancient world, time of Christ and that sort of thing, the days of the week did match the names of the planets. And if you have a Romance language like French or Italian, you could see this quite easily. And then the Romans, those Romans, came and conquered the British Isles at one point in time. And when they got there, they told the Brits that you could have a 7-day week and you could rest on one of these days. And so my ancestors were very happy to hear you could rest at least on one day of the week. And we took that idea up. But then when we kicked the Italians out and sent them back toward Rome, we changed the names of some of the days to the ones that corresponded to our gods and goddesses who had the same sort of function. So after Sunday and Monday, we see Mars is somehow on Tuesday. So who is 2? Well, this is Tuesday, so it has the S in it as the English does. So 2 was the Teutonic god of war, like Mars was. So he's the little red dot in the sky that represents a drop of blood and going around through the constellations being violent. Mercury is somehow Woden's day. Well, who is Woden or Wotan? He was a quick thinking god. Then we have Jupiter for Thursday. So Jupiter would have been Thur, or actually there's a vowel shift there. So he was Thor. So Thor's day became Thursday, and here we are doing that. And then Venus for Friday. Friday was Freya or Frigga, who is the goddess of love and beauty and alliances and that sort of thing. So there's where we get the days of the week. Then we have some questions about planets. So how many planets were there in ancient times? Well, I've just told you Their names are the names of the week. So how many? There were 7 of them. And now, how many planets are there now? Well, for many of us, it was a different number when we were little than we are now. But now there are, does everybody know? 8 planets. And what are their names? The names are different than the ones they had in the ancient days because the sun and the moon are not planets anymore. So we have Mercury and Venus and Earth. Earth wasn't a planet in the past. Mars, Jupiter, Saturn, Uranus, and Neptune, but not Pluto. Now, can you name 3 almost planets? So here would be where I would ask you to write on your little piece of paper if you know the names of any planets that were once planets and not planets anymore. So Pluto is one of those. And then there's Ceres and Vesta. And some of the ones that I think are funny are ones like Maki Maki. Somebody had fun thinking that one up. Now we get to the month. So from the days of the week, we go to the longer period, which is the month, the lunar calendar. Well, why is that useful? Well, it's useful primarily for people who are hunter-gatherers or nomadic and went out of real usefulness when people settled down into cities and urban areas and did farming and large-scale agriculture. But a lunar calendar is very useful for nomadic tribes where you could say, okay, in December, we're going to have a big meeting and an election, and that will happen on the full moon in Pittsburgh, and everybody should go to Pittsburgh and be there for the full moon. And any tribe can look up in the sky and see as the progression gets closer and closer to the new full moon, they better get on the road and go visit them. So it was useful for that sort of thing. Well, how is a month defined? Generally, what we say is from new moon to new moon, or full moon to full moon, or I think the best one, first quarter to first quarter, because that's the one I see most easily up in the sky. And now, how long is a month? Well, Andrew has just told us 29.53 days, or 29.5 days. But we don't have decimal days, and therein lies the problem, as he said. After the month, the next biggest thing is the year, and this is the solar year. Well, why is this useful? This is useful once we settle down to do agriculture, because you can't do agriculture by the moon, despite the Farmer's Almanac. You need to know when to plant the seeds in the ground, and then eventually later they get ripe and you harvest them. Harvesting is not the hard problem. If the thing is ripe, you pick it, and then you cook and eat it. But the big problem is when to put the seeds into the ground, and you have to do that in the spring. And in the spring, the weather is very volatile. And sometimes in February, there's a beautiful warm day and you think, oh, we should plant it now. But no, but then it snows after that. So that would be not a good idea. You have to have some calendar that tells you, all right, it's coming up into the end of March. Now it's the time to put the seeds in the ground of this species or that species. And that's very useful to have for planting. Well, how long is a year? All right, so everybody should know that one. And we just heard it also from Andrew. 365.24 days in a year. So 365 plus a little bit. Now, here's another question. In geometry, why is a right angle 90 degrees instead of 100 degrees? That used to bother me a lot when I was in grade school and first heard about it. Everything they were pushing had to do with decimals, and everything money was up to 100, and measurements were up to 100. And then by gum, we get to angles and it goes only up to 90. What's wrong with this? Well, it's a very ancient problem that our ancestors decided on when they were doing calendars. Okay, the reason is that there are 90 days in a season. So we have 90 and 90 is 180, 180 and 180 is 360. And so 360 is pretty near 365. And they decided that if they made divisions as 365 in a circle, that was a difficult number for the purposes of division and multiplication. And 360 had long been a favorite number. It's divisible by almost everything. And why don't we just call it 360? So they said a year is 360 days. Oh, and the extra 5 is just thrown in at the end, and it doesn't count for this year or that year. And we kind of have that still between Christmas and New Year's. But at any rate, a day is a degree. The sun moves 1 degree against the constellations every day. So now, how many months are in a year? And this is a trick question, and Andrew has told you the answer already. So 12 months of 29.5 days each is equal to 12 multiplied by 30, take away a half, which is 29 and a half then. That's the easiest way to do it. And so 12 30s is 360, and 12 halves is 6. So it's 360 take away 6 is 354 days. So that's how many days there would be in 12 full moons. The difference from a full year, of course, is 365 days take away the 354 days, and that gives you the 11 days, as Andrew said. So the 11 days, if you forget it the first year, by the next year it's piled up to 22 days. You can forget that, but by the third year it's piled up to 33 days, so you really better call that another whole month. So years have 12 months, then another 12 months, and then they have 13 months. And then we repeat that as 12, 12, 13, 12, 12, 13, and thereby we eventually get blue moons every third year. For people who are doing scheduling of religious holidays and things like that, this is a scheduling nightmare. You can divide 12 into 4 nice seasons, 3 months each. You can tell where all the different holidays fall. Everything is nice and repetitive. And then you get the 13-month year. What to do about that? And there was a great deal of consternation and trepidation and problems with what to do with the year that had 13 lunations in it. Really a scheduling problem. And so from early days, from before the time of Christ, 13 was considered a very unlucky number, mainly by the scheduling people. So here's something else that was known at the time of Dante in the 1300s. The Earth is a sphere. This was known way before that. In the 5th century BCE, people knew the Earth was a sphere, anybody who thought about it a lot. So here I would like to ask you actually on your little piece of paper, can you list 3 pieces of evidence that the Earth is not flat? And we'll give a little time for people to think about this, and at least put in your head 3 different pieces of evidence that the Earth was not flat. It'd be really good if you could get pieces of evidence that were known by the 5th century BCE, or if not, you could look at that picture right there and say, oh, that's one of them right there, a picture from a spacecraft. So here's some evidence that the Earth is a sphere. First one, ships going over the horizon. People who had very good eyes could watch ships departing from a harbor, sailing out to sea. And of course, the ship got smaller and smaller and smaller. But as they looked carefully, they could see not only was it getting smaller, but it was disappearing from the hull up. And you saw the banner on the top of the mast last as it went out of sight. So the ship was going over the horizon. And yet when the sailors returned, they never reported that the ship had sunk on the way out and had come back out of the ocean on the way back to port. It was just on the surface of the ocean just fine. Okay. Then there's different stars seen by travelers going south. So from our position in the Northern Hemisphere, we could see all the way to the North Pole and see the circumpolar constellations and stars really well. And you could see down toward the south. But then if you traveled south, like going from Philadelphia to Florida or the Keys, then you could see more of the southern constellations. And certainly you didn't have to worry about conjunctions being blocked by trees in your local backyard, because things would be higher in the sky. So people noticed this long, long ago as people began to travel thousands of years ago. A little more technical, a little more quantitative, is the altitude of the pole star. If you look north and see, well, our pole star now is Polaris. It wasn't always, but people did know where pole stars were at their time. And if you're at the North Pole, then the pole star is right above your head. But as you go further and further south, like here we are here, pole star is at an angle like that. And then as you go farther and farther south, the pole star gets closer and closer to the northern horizon. And that was noticed. Then there's the shape of the Earth's shadow in a lunar eclipse. As occasionally the moon goes into the shadow of the Earth, there's a solid object, so the sun shines on the Earth and causes a shadow behind it. And sometimes the moon goes through their shadow and goes out for a while. And that's always very exciting because it's at a full moon and you can watch it and you can have a star party and everybody goes, oh, look, there it is. It's going out. It's going out. And you could stand and watch the shadow of the Earth as overtake the moon. People noticed, even at the times of the ancient Greeks, that the shadow of the Earth was always curved. And it was not curved as much as the moon is, but curved in a larger circle. And so they did realize, people who looked carefully, that the Earth is probably 3 times bigger than the moon is, or they're about 3 to 4 times bigger than the moon is. And the moon would travel quite a ways to go across our shadow and then come out the other side. You could also notice, so you could say, well, maybe the Earth is like a circular disk, and the shadow of a circular disk, if it's edge onto the face onto the sun, would be a circle. But the lunar eclipses happen at different times of night, and no matter what time of night it is, when they start, the shadow is always a curved shadow. So the only thing that has a curved shadow, no matter what orientation it itself is called a sphere, okay, not a disk. Then we had Aristotene's measurements, which was in ancient times, and he actually measured the circumference of the Earth, and I'll show you a picture of that in a minute. And then we have Magellan, not the spacecraft, but the person who, with a crew, set out to travel in one direction around the Earth and come all the way back to Europe, having circumnavigated the world. Magellan never actually circumnavigated the world himself because he got killed on the way, but his crew did, and the crew members that got back had indeed circumnavigated the globe. It was a rough voyage, so they started out with 3 ships and ended up with only 1 ship made it back, and it didn't have a full crew. Anyway, so then we get to even more modern ones. So photos from spacecraft, like the one I showed you at the beginning of this section. And no matter what spacecraft takes the picture or what continent is facing the camera when the spacecraft takes the picture, it's always a circle. So it's always circular, so it is a sphere. And then we have something that used to really confound me when I was little. Why did the aircraft fly past over the pole if they were going from Cleveland to China? Why didn't they just go straight along westward and they'd get there? No, it's shorter if you go over the pole. And that was difficult to see unless you actually had a globe in front of you. Then there's the Coriolis Force, which determines the direction that hurricanes spin in. This year has been marvelous for the number of hurricanes, hasn't it? We got another one coming, even so late in the season. That the warming of the oceans, especially the Gulf of Mexico, by climate change has really made those hurricanes spin up really well. The design of long suspension bridges. I think this is kind of interesting. Most suspension bridges have two towers, and then they have a loop of wire between the two of them. And if you have very long ones, then when they build them, they have to figure that the stanchions are farther apart at the top than they are at the bottom. Changes the design a little. And then there's the Foucault pendulum, which the first one was in Paris, and there are many of them that spin back and forth and depend on the fact that the Earth is not only spherical, but also rotating. Here's a picture of a lunar eclipse, and you can see when the moon really goes into the shadow on the right, you have the red sunset light in it. But if you look over here, not at the full moon, but just as it goes into the shadow, come back. The shadow here is not the way you would get a crescent moon. It doesn't go from pole to pole, and it's got a more gentle curvature than has the moon itself. So this curvature is about a third that of the moon. Then we have Aristotene's method. He figured the distance from Alexandria in Egypt south to Syene was about 5,000 stadia. And this particular distance was a travel route, and it was well known by camel caravans and the bookkeepers of Pharaoh, exactly how far that was and how much food they had to take on their way and water in order to walk from Alexandria south to Syene. What Aristoteles said is, let us assume that the Earth is a sphere, and that the Earth is, I think we mixed a picture. Oh, there's the picture, sorry. So here's the picture with the camels on the big camels on this Earth, walking from Alexandria to Syene. And he had heard and then was very excited by the fact that on it was, I think, on the solstice, the summer solstice, that if you went to Syene, you could see the sun in the bottom of a deep well. That at that point, when you peered over the edge of the well, you could see yourself and the sun reflected from the bottom of the well. So that meant that the sun was directly above that well, and so a line from the sun to the well would go right back to the center of the Earth. Then he did an experiment, and at Alexandria on the exact same day the next year, he looked at a stick, an obelisk, and noticed that it cast a shadow, and he measured the shadow. The ancient Greeks were really good with geometry, and so he measured the shadow and found that it was 7 degrees. That's 7 360ths of a circle. So that meant that the sun was shining sort of crooked on that object. So either the sun was very close by to the Earth and could cast the shadow just by its closeness to be different, or the sun was far away and the ground itself was sloped by 7 degrees between the two of these places. And he knew that the sun was farther away than the moon was. Otherwise, we couldn't have solar eclipses, which we knew all about. And so it must mean that the sun is far away, and therefore the ground was different by 7 degrees between these two places. All right, so if you know the angle, 7 degrees of that wedge, and you know the outside edge of it, where the camels are, then you could figure out how far it would be all the way around the Earth, and that's called the circumference. So here's where we get to do the math. So the fourth one down, the circumference is 360 degrees divided by the 7 degrees. multiplied by the distance between the two places, which is 5,000 stadia. So that comes out to be 250,000 stadia. And now what is a stadia? Well, one stadia is a stadium. And so a stadium turned out to be 579 feet. And if we divide that by 5,280 feet per mile, you come out that this is 0.11 of a mile, so 1/10 of a mile. Well, that's not very much, but you have a lot of them. So circumference then of the whole Earth all the way around would be 0.11 multiplied by 250,000. And so that comes out to be 27,400 miles, using our miles because I don't deal with stadia very well. And I think all of us know what a mile is. So that's what he got for the circumference of the Earth back in Greek times. Well, the error is only 10% from the equatorial radius we know today and have measured well at 24,901 miles, so almost 25. So it's 25,000 versus 27,000. That's pretty close. And I think that's really amazing for somebody who's got a deep well, a tall object, and a protractor. So it's pretty good. Came out really close. Coriolis effect is shown by this diagram. We now believe the Earth is a sphere and it rotates in 24 hours. We all believe that now. Hurricanes are low pressure areas, which means gas goes from elsewhere toward one of them. It's going down a sink and swirls around because if the gas, like part A here, starts near the pole, it's going very slowly around the pole. And by the time it gets down to where the hurricane is, it falls behind. Whereas on the right-hand side here, we have part B, where gas, air, and clouds from near the equator are pulled toward the hurricane. And when they get there at more higher latitude, they're going too fast, so they overshoot it. And this results in a circular motion, goes counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. We are all concerned with the ones in the northern hemisphere, so you should watch and see if they all circle counterclockwise. Then the sun's motion. Well, where does the sun rise? Well, it rises in the east. Where does the sun set? In the west. That's my direction, so I have that nailed down. But not exactly east and west. We are on a spherical Earth, which is rotating. So then the question is, which direction are you heading right now in your room? And I won't see you, but I hope you could point it out. Which direction are you going? I'm going that way. Over there. It's amazing how many students have no idea which way is east. The sun's path through the constellations makes a nice circle, goes all the way around, and that's called the ecliptic, because only on that path can you have eclipses, because the sun is necessary. So what is a constellation? Some sort of limited area in the sky. They are often given names of characters. Can you name one which is a person? Can you name one which is an animal? Can you name one which is an object? Okay, write those down on your little piece of paper if you have a chance to. How many are there altogether? Does everybody know? They're the same number as the number of keys on a standard piano, which is 88. Coincidence? I wonder. The zodiac, what is that and why is it so important? The zodiac is the path of, is the constellations that border the path of the sun all the way around the sky as we see it from the Earth. So it really is a reflection of our own orbit around the sun, but they didn't know that in Dante's day, but they certainly knew about the zodiac. It has, well, I don't know how many constellations. So here's a nice rendition of the zodiac, I thought, where the constellation patterns are on the left and what they represent are on the right. The ones I think that really look like what they're supposed to are about 1/3 of them. So I think Gemini looks like two twins. I think Leo over here does look like a lion. There's Gemini. I think Scorpius looks like a scorpion. Oh, sorry. And I think Pisces in the lower right corner of the black part does look like two fish on stringers. And then here's an artist's vision of what they might be. So observed motions against the constellations. The motion of the moon, it goes all the way around through the zodiac. It's a slightly tilted circle around the Earth, goes through this big band of the zodiac, the path of the animals. The motion of the sun also goes through ecliptic, goes right through the zodiac, going right round, and it's a more tilted circle around the Earth. Now the motions of the planets, and the modern planets are not the sun and the moon, but rather Mercury, Venus, Mars, Jupiter, and Saturn, at least as Dante's day. And they are tilted circles with retrograde motion sometimes. So that's a new bit of interesting stuff. And what is this caused by? Well, the medieval mechanism was all this was driven by angels. Mainly they flapped their wings. Here's two pictures from various illustrations of Dante. And on the left-hand one, we see the two characters at the bottom labeled D and B, Dante and Beatrice. And then above them, they're in Purgatorio with the flames around them. And again, it's D and B. And if you look above their heads, you see the constellations. The right-hand one, the two fishes, is Pisces. To the left of that is Aries, the ram, which is where the sun was. And then to the left of that is Taurus, the bull. I like the black and white diagram at the bottom because you actually get to see the angels with their wings up, getting ready to make the whole thing run. Here's some pictures of retrograde motion, actual photographs. This one is by Tezel. It was an APOD, Astronomy Picture of the Day, in September of 2016. And both Mars and Saturn, close together in the sky, did a retrograde motion. The path of this planetary motion on the sky is a kind of a Z, a lazy Z, goes this way and then back and then this way again. Mercury's in retrograde. Here's one. This is taken by Cliff Ashcraft, my friend who uses WinJupos. He's taken a lot of pictures of Mars. He loves to take pictures of Mars. And here's some of his really good ones. In 2003, at a really nice apparition. And he has also arranged them on a grid of the sky. And you can see where his pictures fit on the retrograde motion of Mars. So it comes in, whoops, and goes out. This one is, of course, backwards because it's telescopic view. North is down and east is to the right. So sometimes the motion of a planet is a Z, and sometimes it's a closed loop like this one. Really, really lovely things that he did. Something I think is interesting for Lou and other people who are taking pictures of Mars now. If you look at the image of September 5 there for 2003, Syrtis Major is facing us. It's the big dark thing that hangs down, looks like Africa. Because of the global dust storm 2 years ago, part of that is now obscured. So the upper right part of Africa has gone away and is now bright. And it's like Kenya has gone away. Can I do this? Right? There's a little piece there that's gone away. So possible motions of the planets explained by models. So the very ancient one was they were whimsical gods who changed their mind from time to time. So Mars, as you just saw, would be marching along thinking, oh, you know what? By gum, I think I'm going to go backwards today. And goes backwards for a month or so, and then says, you know what? I'm tired of this. I'm going to go forwards again, and trots along forward. Whatever. Then they became astrological omens. So Mars, being the god of war, was very important if you were into foreign affairs to watch what it did. And if Mars started to go backwards, and you and the king were thinking of going to war, maybe you should not think of going to war at that time, but put it off for a month or so and think about what it meant. Then Ptolemy in 135 AD proposed that there were extra circles in the sky. So each planet had the circle around the Earth, and then it had an extra circle. And I'll show you how that works in a minute. Copernicus in 1540 AD said, no problem with that. Earth itself moves and everything goes around the sky, around the sun, and there is no terra firma, the Earth moves as well. Kepler in 1610 AD said, well, yes, planets orbit the sun, but it's not in a circle, it's an ellipse, and the speed changes from time to time. Well, that blew everybody's mind. So here's a cartoon, Johannes Kepler's uphill battle. So you see, the orbit of a planet is elliptical, he says. And his comrade said, what's an orbit? What's a planet? What's elliptical? This is one of the Sidney Harris science cartoons. I think he's hilarious. When we get into the 16 and 1700s, people began to make models of the sky out of brass and wood, and they were generally called an orrery, named for Charles Boyle, the 4th Earl of Orrery in Ireland, who was one of the first people to collect these things. They're just beautiful. Here's another one. Can anybody notice the language on this one? You notice all the gears. It has to take lots of gears to make all these things turn properly. But if you look down here at the edge here, that's clearly Chinese. So I'm not sure who got this one, but I thought it was a lovely rendition. Here we have a diagram of Ptolemy's model of the celestial motions. So this is just after the time of Christ. He used for his input the Babylonian observations. So they had 800 years of having observed the planets through the skies and writing down occasionally when retrograde motion for Mars began and when it ended, how far it went each way, what happened to the retrograde motion of Saturn and when that happened. So there were some ancient actual measurements of these things. So in Ptolemy's model, there are constraints. The model has to be made of circles only and steady speed only. This was what was considered, well, quite normal. Well, of course it would. The planets would move along at a steady pace, that sort of thing. They were, after all, gods, or had been gods at one point. These constraints, though, both turn out to be untrue by a little bit, and that bollocksed up the whole thing. Well, the motion of the moon is a slightly tilted circle around the Earth. The sun is a more tilted circle around the Earth. But now we get to the motion of the planets. They are a tilted circle with an added slow circle called an epicycle. And the epicycle in this diagram is the small circle at the upper left. It goes around and goes at a steady speed as seen not from the Earth, nor indeed the center of the big circle, but rather from a point equidistant on the other side of the center from the Earth called the equant. Now it's getting a little fishy, isn't it? But it worked very well. You could make it do that. It turns out that this, I had thought originally that this was a geometric model and that Ptolemy and his graduate students drew pictures of circles like this on big pieces of papyrus, I guess. But no, it's actually a numerical model. They would see at what angle, what longitude on the ecliptic the planet was, and then they would add or subtract little bits of extra degrees depending on where they thought the epicycle circle was. They never draw the pictures. They would just tote up a whole column of numbers. And they always did one planet at a time for ease of use, but they didn't even think about the planets altogether. So here's how an epicycle is made into retrograde motion. So here you have the same thing. The planet is the black dot on the left smaller circle. And as it is carried around on that circle, while the circle itself moves, it makes the cycloid, which is that kind of loopy thing. And so as you can do this, this thing goes around, the planet is carried inside and then carried outside, sorry. So then there's some subtle observations. It was known from the time of the Babylonians that the 4 seasons had uneven lengths. So for instance, from the vernal equinox to the summer solstice, from spring to summer is 94.5 days. From the summer solstice on to the autumnal equinox is only 92.5 days. So already in Babylonian times, they knew that steady speed was going to be a problem, and you had to do something to fix that, to take care of explaining that. So Ptolemy modeled this with steady angular motion seen from the equant, which is another center point than the Earth. And that will allow you to get, even with small displacements, changes like that. In 1250, King Alfonso X of Spain, King Alfonso the Wise, said, "If the Lord Almighty had consulted me before embarking on creation thus, I should have recommended something simpler." Well, indeed, he had a good idea. So the moon's motion turns out to be not as simple as people would like to think either. There were these Babylonian observations for 700, almost 800 years. And by looking back at those, Ptolemy could use triplets of eclipses to adjust the details much finer than he could with a single observation. And this long time span compensated for individual inaccuracies, so made the motion of the moon pretty accurate. Then we have the precession of the equinoxes. So by the time we get into the 1300s, this is a big problem. So the vernal equinox is when the sun crosses northward across the equator from our view, and has equal daylight and equal nighttime, so equinox, and it's the first day of spring, March 21st. It was observed that the equinox was gradually moving earlier and earlier in the year. And by Dante's time, it was noted in 1308 that the equinox had slid back 8 whole days to March 13th. This is very bad for the planting schedule. In the Divine Comedy, Paradiso section 27, line 142, Dante wrote, "Eventually January would altogether unwinter itself. And then woe to us, what shall we do with the calendar? We have no idea what we're going to do." And this was very upsetting to people who were farmers, and almost everybody was farmers at that time. I think this is their version of climate change. As spring creeps backwards toward January, will January altogether unwinter itself for us? We're in big trouble. Well, the reason actually was due to the 1/100th of a degree per year, which was neglected in the Julian calendar. Okay, 1/100th of a degree per year, nothing much. But to order of magnitude, 1/100th of a degree per year times 1,000 years will get you 10 degrees. And you know, every degree is a day. So 10 degrees is 10 days. Actually, by that point, they only had 8.5 days, but close enough. And everyone knew by 1300 the calendar reform was desperately needed, but they spent another 200 years or somewhat more fighting over it, and finally got it done in 1582. And at that point, we got the Gregorian calendar, which we use now. But by that time, they had to delete another 3 days. So it was 11 days, had to be deleted to the calendar to shift it forward to get it where it should be. And riots ensued in the streets because people got paid by the day or by the week. And yet the landlords charged them rent for a whole month. So they paid for the 11 days in rent, but didn't get it in their salary. It was not a good sign. So I want to tell you about another interpretation which arose in the 1200s, so soon before when Dante was going to write this book, this poem. So in Iran, there were some Islamic astronomers who decided that Ptolemy's model should not just be a mathematical model, but also a physical model. So this was a new idea and not what Ptolemy had in mind at all. that it wasn't just toting up numbers, but they were physical things like circles in the sky. Well, and they also thought all the planets should be considered together, which is another interesting idea. Well, what is it that could be in the sky that could be a circle? And actually they were tilted, so they were spheres, that could be strong enough and solid enough to hold whatever a planet was. Some bright light is on a sphere, but you don't see them. You look up in the sky and there's no spheres to be seen in the sky. So it should be transparent, a solid, transparent thing. Crystalline glass. So we then got crystalline spheres. Now populating the heavens, there is the big one, the little one that had the planet on it. They turned. But now there's a problem. There's a linkage from the epicycle to the equant. So it had to be connected up to the equant so it would turn at the right rate. But if you had a line between those, then it would cut through the sphere and break it. You can't cut crystalline glass without breaking it. What shall we do? All right, so the Margaretha School of astronomers, philosophers, decided they would take away the linkage and then just put little epicycles on the bigger epicycle and have them turn at such a rate that they could do the same thing and replace the linkage with just other little epicycles. So here's a diagram of that. You have the Earth slightly off center in the middle there. The deferent is the big dark circle. Then you have this blue epicycle which goes around, and now you have a small epicycle around where the planet used to be, and the planet is now out. The red dot there on this diagram. Now we have crystal balls as populated by gypsies or fortune tellers. And so you look at your crystal ball to tell what's going to happen next, not in the sky, but in your life. Well, all of this was at the time of Dante. And he was very worried, especially about the slippage of the equinoxes, and realized that the heavens are very complicated indeed. There are circles within circles. There are little circles on bigger circles, and it's all run by angels who are flapping their wings. And I thought this was a really pretty illustration of the Divine Comedy by Gustave Doré, in actually later than Dante's writing of it. But you get an idea of what Dante had in his head for Paradiso for the 1300s, a very complicated thing indeed. Well, the modern explanation, of course, is that everything goes around the sun, not the Earth. And all planets indeed have a common epicycle. It's just the Earth's orbit that affects all of them. And here we have a diagram of the solar system on the left, and then how that plays out as seen from Earth, the little blue thing, what the little red thing looks like, and it goes forward, and then it goes backwards, 2, 3, 4, and then it goes forwards again. It's when we pass an outer planet, or when an inner planet passes us, that it appears to hesitate, go backwards for a while, and then go forwards again. Copernicus said that this was because the sun was very powerful, and a powerful sun deserved to be in the center of the universe. Well, why was the model of Copernicus better than the model of Ptolemy? Some people will tell you that it was more accurate predictions, but no, it turns out actually it has the same accuracy because there were no new data points between the time of Ptolemy and Copernicus, really. So Copernicus put into his model, where the sun was in the middle, the same Babylonian data points that Ptolemy had put into his with the Earth at the center. So they had the same accuracy. How about fewer epicycles to have embroidered on the sky? Well, no. Copernicus and Ptolemy both had nearly the same number of epicycles, not nearly the number that the Islamic people had tried to put in there. So what was it? Copernicus wrote, "At rest in the middle of everything is the sun. For in this most beautiful temple, who would place this lamp in another or better position?" From here, it can light up the whole thing at the same time. Thus, as though seated on a royal throne, the sun governs the family of planets revolving around it. So it was really the philosophy there. And now we know the dynamics of Isaac Newton provide an accurate physical reason for the planets, and they go around the sun, and the accuracy is really very good, except of course for Mercury, who needed Einstein to help it out. So my motto, as I said, was pay attention, be amazed, tell about it. I'm telling about it. What will you tell someone about this topic tomorrow? I hope everybody can write down something so tomorrow when they wake up, they don't always have to talk about the election. So what I learned when I did this research was that it was not multiple epicycles that made us change the heliocentric model, as I had thought. It was the glory of the sun and more elegant mathematics. Speaking about elegance, I thought I'd tell you some other stuff. So quickly here are some quilts. I'm a quilter is another hobby. The one below the writing is Judy Dale's Star Shower, not meteor shower, star shower. I think that's just beautiful. She used to live in New Jersey, and I used to know her then. To the right of her, there's the circular one, which is Bette Bellinger's A Quilter's Night Sky, which is very detailed and has all sorts of beautiful colors and patterns in it. Then the two little ones in the upper right are quilts that I have made. The brownish one on the left is called a stellar model. And you can't see it on this small rendition, but there are equations embroidered in the beige parts. And they're the equations of stellar structure. And when I put it into a contest, the judge said, I wonder why she has put all these weird things in, not understanding stellar structure at all. And the one on the right is called Imaginary Star. I hope some of you will realize why I named it that. It is a Ohio star or Texas star as the pattern, but this one is imaginary, and you guessed it, there are no green stars in the real sky. I thought I'd also tell you a little bit about my favorite constellation. So this is Ophiuchus, the Serpent carrier. It's actually the 13th constellation in the Zodiac now. As time has gone on in the last 2,000 years, things have shifted a bit, and the Zodiac goes through Ophiuchus a little bit. So the story of Ophiuchus is he was a young man who went out to find his fame and fortune in the desert in ancient times, found the snake of all knowledge, and asked for the knowledge of medicine. He held the snake for a while like that, and then eventually just wrapped him around his neck. And the snake went with him for several years, and they called it medical school, and he taught him all about medicine. He often carried the snake wrapped around his walking stick. So we see in the icon to the right there, emergency medical services, the walking stick with the snake of all knowledge wrapped around it, a symbol of modern medicine and doctors. I like this very much. So I helped Mac Adams, a sculptor, design the sculpture on the left there, aluminum and steel. It's at Montclair State University in the campus. That man looking up at it is my husband. And so you could get a sense of scale. He's 6 feet tall. And when the sun is in the right direction, it casts a shadow of that mass of aluminum there that falls on the disc on the ground. And you see that on the right. And here we have me and some of the graduate students some years ago on the proper day, looking at the shadow of that mass of aluminum. And what you see is Ophiuchus the man with his arms outstretched, holding the snake. And you see the snake's face looking at his face. So that's our Ophiuchus sculpture. And you are all invited to come see it if COVID goes away. The day in question is graduation day. So it happens May 24th every year, or the whole week of May 20s. And you can come and see it. It's at noon, local noon. So that's 1 o'clock on your watch. Please come and see it with me sometime. Here's some references of the various books that I have read for this. Thank you very much for your attention. So let's see.
That's great, Mary Lou. And we usually have a question and answer period.
Okay. I don't know how to get the thing back.
I can, you mean to stop sharing?
Stop share, yeah.
Yeah, I should stop sharing, right?
There you go.
There you go.
No, no, no.
No, you did it.
No, you did it. You're good.
Is it okay now?
No,
I don't.
Can turn it off. I'll turn it off, and then your problem is solved.
Thank you.
So problem
Very
is
good.
solved.
Does anybody have any questions?
Presumably in English, not in Dante's
Oh
Italian.
yes, please. I don't speak Italian. Even if you do, you could translate.
I could do a very bad translation.
Yes, I have a version which is in English, which is really what I needed.
Yeah. Any questions? What was Mary Lou, you asked about the constellations and it like went by too fast. You asked how many constellations are people, how many are animals? What was the other category?
An object. No, I just wanted you, can you name one? So what person would you name as a constellation? Name a constellation which is a person. Harold, what you got?
Constellation that's a person? Perseus.
There you go. All right. Virgo. Very good. Anybody else?
Gemini.
Gemini. Two persons.
Two persons, right.
Very good.
Actually, four. You got Romulus, Remus, Castor, and Pollux, depending on what Romans or Greeks, right?
Well, there you go. Okay. So how about an animal? There's lots of animals.
Lots of animals.
Michael, what do you like?
Aries the ram.
Aries the ram. Okay.
Taurus the bull.
Harold, what do you like? I see you with the blue background.
I like Taurus.
Taurus the bull.
So easy to see.
Yes. Yes, I like that one too. It looks like.
Yeah, so do I. The V with the Aldebaran V, right?
Although Scorpio was fabulous this summer.
Oh yeah.
It was the first time I actually saw the entire thing and could make it all out.
Where did you go?
Cherry Springs.
Oh, there you go. Right. You should go to Florida. So I've been told that every culture that has scorpions in it calls that the scorpion.
Wow.
And the ones that don't have scorpions call it the fish hook. Okay, so then the hard one is an object.
Libra.
Well, there's tons of objects, right?
Libra. Libra.
Corona Borealis.
Very good. The crown.
Well, a lot of the southern constellations are named after objects.
Right, but nobody knows those.
Microscopian.
Yeah, telescopium and
Triangular.
Homer Simpson's underpants. Oh wait, that's an asterism.
Does Coma Berenices count as person or thing?
So Henry, what did you say?
Does Coma Berenices count as person or thing?
Yes, hair is a thing. There you go. Very good. That's very
And
good.
how about the centaurs as being both person and animal? Person Sagittarius.
How about Sagitta? Sagitta is the thing.
An arrow.
The arrow.
Right.
So it's kind of interesting to think about those. If you total it up, most of them are animals because these were named by hunter-gatherers and they were really fond of animals. Nobody named Leo the lion. That's a good one.
Well, most of the zodiac is animals. That's why it's called Zodiac.
Exactly right. Very good. Very good. So you know which one was the last one to be added? It's the non-animal.
It's the Ophiuchus, right?
Well, that's really, really, really recent. I was thinking of Libra. Libra the scales. By that time, we were settled down into towns. We needed justice. We needed an accurate count. Something. I don't know. Right. I am very impressed to know that somebody else has actually read this in Italian. Some of my friends who were raised in Italy had to memorize whole stanzas in Italian and be able to say them out.
Oh, we didn't have to do that. I mean, I could read it out loud, but that would bore everybody here. But it's an amazing language.
Is it very close to Latin, really?
The vocabulary is very, very close. And the grammatical rules are, the grammar rules and syntax are comparable to Latin with declensions and stuff like that, and the way verbs are handled. So with a Latin background, Italian is very easy to pick up.
You had 4 years of Latin in high school or college, or?
Yeah, I had the Latin in college, in high school, and then I started undergraduate school. I went right to Italian.
Very cool.
I took the first introductory class, and it was totally really boring. I said, I want to jump into literature. And the professor said, you're going to have to take a placement exam, which I took. And she said, you should really do the other half of the grammar course. And I said, no, I'm going to go ahead with the literature course anyway. And then 3 years later, as a senior, they said, well, you're not going to graduate because you never took the other half of the grammar course. And I had to go to the Italian professor and go, well, I did get B's in the class. She said, yeah, all right, you passed. So.
What school did you go to?
Penn, undergrad.
Okay.
Yeah. And many years later, we were going to Italy, and I contacted my Italian professor, who had since retired, and said, I'm sure you remember me as a huge pain in the ass, but can you point me in the direction of somebody who could, help me get my Italian back up? And the fact of the matter was, she didn't remember me at all. When you're a college student, you're 20, and everybody older than you seems like really mature. She was she like just finished grad school. She was a frazzled, a junior professor trying to find her way in the academic world. And she was completely distracted. I barely existed in her universe.
Oh, I want to show you the shirt that I have that has everything going round.
Oh, nice.
Nice.
So if I'd been there in person, you would have seen it better. Sometime I'd like to come down and meet you people in person.
Yeah, please do. That sculpture looks fascinating. Where is Montclair? Where is Montclair State?
It's in northern New Jersey.
Okay.
15 miles west of Times Square.
Okay.
Wow.
So we're very near Manhattan.
I would love to see that sculpture.
Yeah.
That sounds really cool.
Really, really cool. The sculptor was such a neat guy, and he made it happen. And so you come there at like 12:30, and everybody hangs around waiting for 1 o'clock to come, and it gets better and better and better, and then suddenly it coalesces to this man holding the snake by the throat. And saying, will you teach me medicine? And the snake said, yes, I will teach you medicine. And he became the first medical doctor. The rest of his story is a little, I think, weird. But at any rate, so after becoming a medical doctor, he goes from village to village in the Middle East. So this is Babylonian, treating people for whatever illness, and mainly cooking up berries and leaves and giving them the juice, right? And at one point, he and the snake come to a village where somebody has just died. And there's all sorts of weeping and wailing and keening and whatnot. And the snake says, quick, they're not really dead. Go over there and breathe in their mouth and pump on their chest rhythmically, and the person goes back to life. And he says, someday we will call this CPR. And everybody is so impressed that they just throw money at Ophiuchus and his snake. And he says, oh, this is really, really cool. We got a lot of money in that village. And so after he takes the snake back to the snake's house, he decides that his specialty will be no more house calls. He's going to do raising of the dead. Mm-hmm. And the snake has already taught him, this is a myth, of course, that you can raise the dead even if they've been buried for some years. So he sets up camp, and he has a big house with a big courtyard and everything, and lets it be known that if people have a dead body and a bag of gold, they could come to his house and give him the body or a bone or something, and the bag of gold, and he will do stuff, and then the person will come back to life. Mm-hmm. And that's the way he makes his living. And he does very well. But in those days, the god of the underworld, do you know who the god of the underworld was, Harold?
Hades?
Hades, or Pluto, gets all upset about this because people are now flittering back from the region of the dead back up into the surface of the earth. And you think, well, oh, for heaven's sakes, why would Pluto get so upset? Because there are thousands and thousands and thousands of people there. Well, what is he going to miss one or two, who are the people with the bag of gold relatives? But you think about it, the people that have relatives that have a bag of gold are also the ones that had leisure time and they learned how to play chess and they could sing opera and they could speak Italian and things like that. And they were the ones that Pluto hung around with because he was the king of the underworld. And now his friends are scooting back up to the surface of the earth, and that's not good for him. So he went to his brother, Jupiter, and he said, you know, I want you to take care of this guy for me. And Jupiter said, all right, I will kill Ophiuchus for you. But he's not all-seeing, so he has to wait and look for him and only sees him when the last family comes with a dead body and a bag of gold and puts it down in the courtyard, and Ophiuchus comes out into his courtyard. So then Jupiter spots him. And he takes the bag of gold and gives it to the servant who takes it away. And he starts to do his stuff over the body. And Jupiter says, I see you, throws the thunderbolt, kills him, throws him up in the sky. So that's why we have Ophiuchus in the sky.
It's basically the Al Capone story. He gets busted for tax fraud.
Something like that. But I think you should be interested in the next bit. So the family of the dead body have paid the gold and they have not got the service. So they scream and cry, and Jupiter says, oh, all right, for just this once, I'll split the difference with you. I'll take the dead body and I'll fling it up in the sky and you can see it half the year and you don't see it the other half the year. Is that good enough? And they said, yes. The dead body was Orion. That's why we have Orion in the sky. So then the people whoever made up this myth was really good at this. So in the sky, what's the relationship of Ophiuchus and Orion?
Opposite sides?
They're exactly opposite on the celestial sphere. So when one rises, the other sets. You never see Orion and Ophiuchus in the sky at the same time, so that the spell cannot be broken.
How do we know they're not the same person then?
Ah. And where did they hide the body, right? But at any rate, so I think it's very, very good. And they both have navigational stars in them. So you navigate by Orion, then you give it up, you navigate by Ophiuchus. And you can use one or the other. It's like the Big Dipper and Cassiopeia that are opposite in the sky. But I love the story. I think that's really neat.
I wonder if Mary... I wonder if Mary... I'm sorry, go ahead.
What?
Wait a second, Michael. Go ahead, Henry.
Yeah, more likely is Orion was not happy with this business, and Ophiuchus sees him waving that club, and he's keeping as far away from him as possible.
Okay, that's another good idea. Not good to have a guy with a club after you.
Right. Michael.
I was wondering whether, when you're talking about the bringing back of the dead, whether or not Mary Shelley had ever known that story you just told.
So this is where doctors came from. That's why they always have this caduceus, which is the stick with the snake wrapped around it. Ask your doctor. I bet they don't know what that is.
There's enough doctors in here.
Are you a doctor?
A few of them here.
Did you know that story?
I didn't know the story, but you know what? I thought there was a. They did this theme on What We Do in the Shadows in one of the episodes. Have you guys ever seen that? Where they had one of these vampires trying to raise somebody from the dead, and he was never successful. But no. I think there was a parody off this. Now that you mentioned it, it's actually pretty clever.
Now, isn't the story also that Scorpius killed Orion, and they're on opposite sides of the sky?
Yes, yes. So there was a battle with Scorpius.
And Ophiuchus and Scorpius are almost attached.
They're hanging out together. Yeah.
Right, one below the other.
The people who made up these stories looked at the sky and thought about it a lot and thought how to make really good stories of these constellations.
A lot of them are collected by Ovid and Metamorphosis.
Yes.
I mean, they didn't have Netflix back then. So
No. But they also didn't have light pollution.
Right.
that's right.
That's true. That's true.
Jealous.
Right.
That's why I'm always sort of amused when I read about 19th and 18th century European astronomers, quote, discovering things, like Charles Messier discovering all these objects. They were up there for thousands of years. I'm sure people saw them.
Right. But he wrote them down.
Right.
That's right. He cataloged them. Right.
Which is a good thing.
Mm-hmm.
And he was looking for a comet. Poor Messier.
Right. Yes.
He eventually did find one.
Right.
Yes. Poor guy. He's known for his list of discards.
So is Comet Messier ever coming around again?
7,000 years or something like that.
He would be very jealous of David Shoemaker Levy.
Mm-hmm.
Who?
David Levy. David Levy.
David
Levy.
and Gene
Carolyn
Shoemaker.
Shoemaker and
Right,
Gene
right.
Shoemaker.
Right.
Right.
Thank you.
Yes.
And
Poor
Carolyn
Gene.
Shoemaker.
Yeah. Poor Gene. Yeah. Yeah.
Now you go with Joseph Linear and Bill Neo Eyes. Let's go.
Exactly.
I like Bill Neo Eyes. I look forward to meeting him. Oh, that's funny. That's a good one. Yeah.
You know, I always tell my students in electronics, you know, the transistor was named after Robert Transistor, and Bill Diode.
But you have a chance to actually put a female name from time to time, and I bet you don't.
Yeah.
So what was the SCR named after that?
That was a Mary silicon controlled rectifier.
Okay, there you go. There you go.
Well, the transistor was female because it was named after Mr. Transistor.
Oh, excellent. That's a good one. Yeah. Yeah, very, very good. Very good. Well, here's a question for you, timely. Today is the 6th day of November. It is the birthday of the person who invented the saxophone.
Person who invented this.
Who was it?
I do not know.
Louis Sax.
I used to know this as somebody who plays the saxophone.
Come on, Jeremy, just say it right out.
Jennifer Sachs.
No, you just say Mr. Sachs. Of course, it was a Mr. at that point. So his first name was Adolf.
Oh, that's right.
Yeah, my dictionary just says Sachs, the inventor, without giving a first name. Unhelpful.
Unhelpful, yeah. Yes. So he was from Belgium.
Mm.
Where the heck is this watery background that you have?
That is the Perkiomen Creek at Runs, just north of Collegeville, Hurricane Isaias. Those metal towers in the background, hang on, I'll get out of the way for a moment, are part of a miniature railway bridge, and the actual railway lines are 5 feet underwater. We reckon that the water when this photo was taken was 12 feet above flood stage, 18 feet above the normal water level in the creek. There's a National Weather Service gauge a couple of miles upstream, and that reported 10 inches above the all-time record high. It got a bit soggy around there.
So this is in Pennsylvania?
Yes.
Yeah, it's about just north of Philadelphia.
About 25 miles outside of Center City, right?
Down the street from my house.
What's the name of the creek? I'm going to look it up.
Perkiomen Creek.
Perkiomen.
I didn't realize you lived so close to me, Henry.
Where are you exactly?
Straight up 29, like Perkiomen Creek, right where it's dammed up at the park.
Yeah, I'm in Collegeville on 9th Avenue.
Okay.
So I'm only a couple of miles walk
I
from
can just hop in my canoe and
where this photo
sail
was
on down.
taken.
Is it flooded now?
Not when I last looked. That flash flood only lasted for a couple of hours. The problem was we got about 8 inches of rain in 2 hours, all in that valley. So you got an incredibly flood, but it only lasted a few hours.
Wow. I'm glad I'm not there.
Did have quite a lot of cleaning up and drying out to do after that.
Mary Lou, do you recognize the photo behind me?
This is a very beautiful waterfall. Looks like a Buttermilk Falls that I knew once, but I'm not.
Lower Falls at Robert Treeman.
It's beautiful.
It is.
Are you a Cornellian?
I grew up in Ithaca.
Very good. Lovely place.
It is.
Yeah, especially in the summertime.
Yeah, this was taken in June of this year.
Oh, very nice. So are your folks still there?
They are. They are. Well, they live in Lansing, north of Ithaca, so.
Very nice. Very good. All right. So do you ever go back? Well, who knows, anybody can go back anywhere now.
Well, I was going to go see, my dad had a stroke back in March, just before school started.
Sorry.
He's on now, but I was going to go up to see him a couple weeks ago, but he was diagnosed with COVID, but he's not asymptomatic right now, so I don't know. I'm not going to go for a while, but.
Okay, so if you ever get to go again, I could give you a homework assignment.
Sure.
So if you go to Olin Hall, which is the chemical engineering building, it has an east entrance, and the east entrance was refurbished a few years ago with all sorts of cabinets and displays in it by me and my husband. So it's the west-east entrance.
West east entrance, okay.
We're west and it's east. So why they did that, I don't know. It's just silly.
Yeah, my wife I think she worked at Olin Library.
Oh, okay. Well, that's another whole building.
Yeah.
So at any rate. Oh, well, good to make your acquaintance.
You too.
Were your parents connected with Cornell?
No, not at all. My dad worked at NCR for years and years, up on the South Hill.
Okay. Very good. Well, thank you.
A couple of pedantic points about the lecture, Mary Lou.
Oh, sure. Tell me what you noticed.
One, the change from the Julian to the Gregorian calendar in 1582 was only 10 days. It went up to 11 days in 1700 for areas that hadn't yet, because remember that the Pope is a Roman Catholic, and in the 1580s, Europe was split with these wars where you can't figure out whether religion is an excuse for the politics or the politics is an excuse for the religion. So, well, the Protestant parts of Europe didn't immediately adopt the change, and it pretty much happened in a different way. Sweden, I think, simply didn't have any leap years till they were back in sync sometime in the 18th century. Russia didn't change over till after the revolution in 1917, which is why the Russian Orthodox Church is still too weak, and it's now 2 weeks out of whack with the rest of us.
Well, they have 13 different time zones. That has a lot to do with it too.
And then the Chinese, yeah. Yes, thank you very much. I'll change that part. You're right. Do you notice anything else?
I've only read Dante in English, and that was many years ago, Dorothy Sayers' translation. But as I recall it, it was Virgil who escorted Dante through the Inferno and Purgatory. Beatrice doesn't show up until Paradiso, because of course she was in Paradise all along.
I think that's right.
Okay. Yeah, well, that's the part I read. That's the part that's about the sky.
Well, the Inferno is the fun part because he absolutely skewers anyone who's ever crossed his path. Imagine if Trump were literate. Okay, that's basically what you're dealing with. If he could actually read and write, the Inferno would be something like that.
Oh dear, oh dear. Yes. So I guess Philadelphia is still counting. It's you folks, huh?
Yep.
Yeah,
I heard we were still counting.
Mhm.
Hoping,
No, stop the count. Stop the count. It's fraudulent.
You can't stop the count unless you have a piece of garlic and a silver cross.
There's
one vote, two.
Yeah, that's good. That's a good one. Yeah.
My blood pressure is definitely a lot lower today than it has been for the last week and a half.
Yes.
I was losing a lot of sleep over this, and I just finally gave up reading it until a couple of days, right?
But remember, mathematics or the completion of a count is only one part of things, right?
Right.
Yeah.
Then you have the slugfest.
Right.
I'm not worried about the legal end of things.
Okay.
I mean, it'll be a war of attrition, but I don't. First of all, his legal staff is not particularly good.
He's got Giuliani.
Like I said, his legal staff's not particularly good.
Right.
Non-zero number of observers in the room.
Right. There you go. Exactly, Katie.
Barack got Giuliani really good.
Yeah.
If you guys saw that.
What was that?
The Barat movie, he got Giuliani good.
Yeah, he did.
He got all of Trump's clan good. At least the ones that weren't prosecuted or under house arrest or in jail.
Well, Jeremy, do you want to stop the recording?
Yeah, I think we'll call this an end to the YouTube and to the recording for tonight.